Good morning, everyone. My name is Chaya Pandey, and I am a Principal Product Manager with AWS Lambda. Welcome to reInvent. And although we all couldn't be there to talk about all the exciting launches and interact with all of you, I'm still excited to talk to you about serverless pricing, total cost of operation, and how to think about your serverless application TCO. So let's get started. Let's quickly go through the agenda. We will start with discussing a framework for modern applications and the three pillars of serverless TCO. Next, we will take a look at Lambda pricing, followed by a double click into provision concurrency and savings plan. And finally, we'll wrap it all up with a revamp of the latest Lambda pricing changes. So let's get started. First, let's look into how our customers think about modern applications and their serverless TCO. Modernization is a top priority for businesses. Forrester estimates that 65% of North American companies have already adopted the cloud, and IDC predicts that in the next few years, over 50% of ICT, that is information and communication technology, spend will be for digital transformation. This is a process that almost every organization is going through today. When organizations think about modernization, they typically address the 5 areas here. So, first, they are customer obsessed. They want to create frictionless, immersive, and consistent experiences across multiple channels. Second, they are organized for value to achieve leadership alignment, funding, and structure around discrete business outcomes. Third, they want to be able to serve a learning organization focused on experimentation by creating and testing hypotheses. Fourth, senior leaders understand tech deeply and use it to inform business strategy. This does not mean becoming a technology company, but making sure that your business strategy is aligned with the feasibility that technology can provide. And last but not least, strategic use of data is a core asset and is used in all decision making. Making data easily accessible is one of the key considerations when building an app. Modern applications can be characterized along 5 technology vectors. First, there are architectural patterns that are moving towards modular services. Second, software delivery practices that are increasingly automated and standardized. Third, effective data strategy, which offers a distributed and fit for purpose data infrastructure. Fourth, operational model needs to be as serverless and automated as possible, and management and governance is everyone's responsibility rather than the purview of one team. Applications built in this way enable you to achieve the agility you need to innovate on the behalf of your customers. And serverless technologies are the best way to maximize agility because with serverless, AWS takes on more of the operational load from you. So what do we mean when we say serverless? When we say serverless, talking about applications that are built with technologies that eliminate the need to manage servers, scale nearly infinitely automatically, use a pay for what you value pricing model, and are automatically highly available. This strategy, often referred to as serverless operational model, enables you to dramatically reduce the time spent on things that aren't core to your business, like managing servers, for example, and focus on the products that drive your business. Many customers have made a decision to achieve this value through a serverless first strategy, or a decision to use serverless services as a preference unless the use case or workload demands that they choose otherwise. Customers like iRobot, Alma Media, and Fender are all serverless first. When developers are toying around with a Lambda function or using it for cron jobs, they are probably incurring such a low cost that the pricing model doesn't impact the business decision making. But as you adopt a serverless first strategy, you need to recalibrate. Rather than overpaying for pre provisioned servers, your costs are aligned to your usage. And now you need to think about how you are utilizing your servers in parallel with your costs. When thinking of total cost of operation, it's worthwhile to think in terms of a holistic picture. For a serverless architecture, customers usually look at three key categories: infrastructure cost, development cost, and maintenance cost. Infrastructure costs compare directly to a pricing model a customer is used to, maybe on a server based architecture. How much do your servers or Lambda functions cost to execute? Then there is also maintenance and development costs. Development costs are the number of developers on the team and the time it takes them to deploy products and features. And maintenance costs are captured in how long does it take your team to provision, scale, patch, and manage your servers. With serverless, your maintenance and development costs go down dramatically. So let's really look into infrastructure costs. AWS Lambda comes built in with three key benefits. First, high availability through multi-AZ implementation. If you were building your own solution, you would have to implement your own failover logic and capacity allocation across multiple AZs. This is done automatically for you when you use Lambda at no additional prices. Second, Lambda offers an automated load balancing. When implementing it yourself, you would need to use application load balancer in conjunction with CloudWatch metrics for load balancing, and you would have to manage your application and latency to meet your traffic needs, something that's automatically taken care of by Lambda provision concurrency. And last but not least, Lambda lets you configure resources at a per function level, which always assures a better utilization than what you would achieve by provisioning servers. Servers are underutilized spatially whenever your workload is running below your peak because you provision servers on the basis of the peak of your traffic expected, but that's not usually the traffic level at which your workloads run. Secondly, your servers can be underutilized temporarily whenever your workload is not running but needs to keep the instance running for better latency or any other reason. As you only pay for hardware, your function needs utilization of resources on Lambda is higher than what it would be on a server-based architecture. Here is how one of our customers, moving from another cloud solution to AWS serverless, had to say about their infra cost savings. A rough estimate based on a customer survey values the infra cost savings at $2.24 million per organization, which is about $80,000 per application per year. The next big piece of your serverless savings is maintenance cost. Time to access compute and storage resources is a useful proxy for IT agility. This data shows how, according to an IDC study, AWS serverless platform customers have reduced the time required to access compute and storage resources to minutes, with on-premises migrators seeing reductions from hours or even days, and migrators from other cloud solutions seeing substantial relative reductions. With typical deployments measured in minutes, study participants have made significant strides in minimizing the extent to which extending and making changes to their IT environments exerts a drag on their business operation. For example, one organization reduced the time needed to deploy new compute resources from 10 days to 1 hour by moving from on-premises to AWS Lambda. And the AWS serverless platform On an average organizational basis, study participants reported cutting the time required to deploy new compute by an average of 89% and new storage by 96%. So the TCO of serverless computing tends to be lower than VMs, according to a 451 research, even when the VM is hosting containers, because there is no need for developers to provision, configure, and manage infrastructure. When a serverless function is active for just 3/4 of the month, it only takes a 10-minute savings in operational overhead for serverless to beat VMs on TCO. So overall, when we look at our customers, their development teams can now develop and release 18% more applications and 115% more new features as compared to their business counterparts, because they are speeding up development cycles by 76% and 66% faster for new applications and features respectively. For example, an on-premises migrator cuts its development lifecycle for net new application from 6 months to 1 month with the AWS serverless platform. And an organization that moved from a mixed environment reported quintupling the number of new features it delivers to the business per year. This means that development teams generate and deliver more value to their business, with IDC putting the average productivity increase for their development teams at 33%. Development teams capture significant productivity gains with serverless because they need less time to deliver an increased number of new applications and features. Further, teams responsible for IT infrastructure and application management require less time for day-to-day monitoring, deployment, and support activities. We estimate the annual value of efficiencies and productivity gains at an average of 4.64 million per organization and about $165,000 per application. Organizations increase the velocity with which they can address business opportunities, which results in higher revenue. Further, end users benefit from faster delivery of new applications and features. IDC quantifies the value of revenue and productivity gains at an average of 3.21 million per organization, or about 114K per application per year. With these three pillars to think about serverless TCO under our belt, let's quickly recap Lambda pricing. So jumping right in, when we launched Lambda a little about 6 years ago, we had two pricing dimensions: requests and durations. You are charged based on the number of requests for your functions and the duration, which is the time it takes for your code to execute Lambda. To execute. Lambda counts a request each time it starts executing in response to an event notification or invoke call, including test invokes from the console. Duration is calculated from the time your code begins executing until it returns or otherwise terminates, which used to be rounded up to the nearest 100 milliseconds, but now is 1 millisecond, which I will talk in detail in a few slides. So the price depends on the amount of memory you allocate to your function. In the AWS Lambda resource model, you choose the amount of memory you want for your functions and are allocated proportional CPU power and other resources. An increase in memory size triggers an equivalent increase in CPU available to your function. So with that quick recap of Lambda pricing, let's look at provision concurrency. While customers loved the ease of use that came with Lambda, they wanted to run an even wider range of applications on Lambda, including applications that had strict latency requirements and that needed to support high-velocity traffic bursts. So we launched provision concurrency to primarily address two concerns for Lambda customers. First, it enables fast scaling by allowing customers to scale up to the entire provisioned amount at once, going around Lambda's default burst limit of 3000 concurrent. Second, it eliminates cold starts by pre-initializing sandboxes to support applications that have strict latency requirements. These use cases mostly included applications that have either a direct interaction with end users, have strict regulatory requirements, or leverage languages that have a slower cold start time or require large deployment packages. When we exceed the provision concurrency, it automatically switches to on-demand Lambda. You can also configure Lambda to throttle requests above the provision concurrency. In this example, the traffic spike exceeded the pre-provision concurrency and Lambda started additional sandboxes using its default behavior. This is what has caused the P100 traffic spike for the cold start of new sandboxes. This chart shows how we would manage our provision concurrency hitting just the right times. Through the integration with application autoscaling, you can schedule concurrency provisioning to autoscale with your traffic. Provision concurrency is configured in increments of 5 minutes. If the traffic exceeds the provision concurrency, it is handled by on-demand Lambda and adheres to the default Lambda limits and behavior. Through the integration with application autoscaling, as I already said, you can configure your provision concurrency to scale up just when your traffic scales up. Now let's look at provision concurrency pricing. The duration of provision concurrency period is measured in increments of 5 minutes, while the function execution duration is metered just like regular Lambda, but at a lower rate. We still use the GB time unit measured to calculate cost, so the size of the Lambda function still matters alongside the provisioning period. Now let's take a look at compute savings plan, a new option to optimize your Lambda bill that we launched earlier this year. Savings plan are a new pricing model that offer deep discounts on EC2, Fargate, and Lambda usage. You can sign up for a pricing plan by committing to a consistent amount of usage, something like $10 an hour, for a 1 or 3 year term. Savings plans offer the exact same discounts as RIs, but with greater flexibility. That is for EC2. These discounts apply across EC2, Fargate, and Lambda usage, even as the compute requirements that a customer might have change. When customers sign up for savings plans, they will be charged discounted prices on their usage up to the hourly commitment. Any usage beyond the hourly commitment will be charged at regular on-demand rates. So AWS offers 2 types of savings plans: EC2 instant savings plans and compute savings plans. While EC2 instant savings plan provide the deepest discount in exchange for a commitment to usage of individual instance families in a region, compute savings plans provide the most flexibility and help reduce usage costs by up to 66%. These plans automatically apply to EC2 instance usage regardless of instance family, size, AZ, region, OS, or tenancy, as well as Lambda and Fargate usage. For example, with Compute Savings Plan, you can switch from C4 to M5 instances, shift a workload from Fargate to Lambda, or from one region to another. Saving plans offer you the same deep discounts as EC2 RIs with the flexibility to make a simple monetary commitment instead of making commitments to specific instance configurations. And getting started is fairly easy. Customers can sign up for savings plan in a few simple steps using the AWS Cost Explorer. If you would like to make a capacity reservation on EC2, you can reserve with on-demand capacity reservations. And if you have active savings plan, then your capacity reservations will be charged at savings plan rates. So now let's really look into how does savings plan apply against a customer's commitment. So this is just an example that I've put together, not necessarily any customer's usage. This is just hypothetical data. So let's consider an hour's worth of usage for a customer who has a savings plan commitment of $100 per hour. Now, how savings plan work is that the customers make a commitment, in this case $100 per hour, then their usage is billed at discounted rates offered by savings plan till the total spend matches customers' savings plan commitment. So in this data here, you can see that the first column shows customers spend according to public prices, while the third column shows their spend according to savings plan. The last column shows just the cumulative sum of column 3. So we keep looking at what point does the total spend as calculated using discounted rates match the commitment level. In this case, you will see that their usage for all services except Lambda requests is covered by the customer's commitment of $100. So this $100 has already been paid through savings plan. All of that usage will be covered. The only thing that won't be covered is Lambda requests, which will cost them about $5, and the customer will end up paying $105 for this hour. So that is how it applies. Another important thing to note is the order in which services are applied to savings plan commitment. For example, if EC2 and Fargate and Lambda each had $100 worth of usage, using the discounted rates for this particular hour, which service would apply to savings plan first? So what happens is, it's very simple. The service with the highest discount percentage under savings plan is charged first against the customer's commitment. So in this example, you can see that the services are sorted in descending order by savings plan discount. So if you have a particular level of savings plan commitment, it will first apply to the most discounted service, which in this case is EC2, then to the next discounted service, which would be Fargate, and then to the third discounted service, which would be Lambda, sorted by the magnitude of the discount percentage. Now let's look at a slightly different variation of the same data. Let's say that for the next hour, this is the usage for the customer by service where the EC2, Fargate, and Lambda compute usage sums up to $99 with $1 to spare in their savings plan commitment that can now apply to Lambda requests. Now looking at the last row here, excuse me, at 20 cents per million, this customer had 25 million requests for the hour, of which $1 worth of requests, which is 5 million requests, will be covered under savings plan, while the remaining 20 million requests will be covered under regular rates. So the customer's commitment of $100 per hour will cover $100 of this total usage, and $4 or 20 million of the requests will be charged on their regular bill, so their total bill will be $104. Now let's take a look at recent Lambda pricing improvements. In our attempt to bring highest value to our customers for the resources they are assigned for their Lambda functions, we have reduced Lambda's duration billing granularity from 100 millisecond to 1 millisecond. This will lower the price for most Lambda functions, more so for short duration functions. For example, a function that runs in 30 milliseconds on average will see a discount of 70% because earlier it used to be charged for 100 milliseconds per invoke, and now it would be charged for actually 30 milliseconds per invoke. This launch will further improve the utilization of resources allocated to your Lambda functions and will improve your TCO as compared to server-based architectures even more. Remember, we must consider all of your CapEx and OpEx costs when looking at TCO. So include infrastructure costs, developer costs, and maintenance costs when looking at your total TCO for serverless applications. According to one of our smaller customers, they saved $840 per month per process in their maintenance costs by going serverless. Most customers have thousands of such processes per workload, translating into $1 million savings per month per application. Putting the infra savings and maintenance cost savings together, we have found that an application that runs for 3 quarters of the month, which would be typical for any application running during weekdays, just needs to generate 10 minutes of savings in operational overhead for serverless to beat server-based architecture on TCO. We have already seen that the actual savings in maintenance cost are 88 to 96%, translating to day or weeks, much higher than the 10 minutes needed to break even. To sum it all up, based on interviews with 11 AWS customers, we have seen that organizations will achieve benefits worth an annual average of $382,000 per business application, or $10.7 million per organization on the AWS serverless platform when compared to an on-premises or server-based architectures. With that, I thank you all a lot for your time today, and I wish you happy holidays. Please don't forget to complete the session survey. Thanks a lot for your time.